morning children. Today we are going to discuss 8th class toppers JEE NEET foundation. So the topic is work power energy. So the amount of work done is nothing but whenever force acts on a body displaces in the direction of the force. That is called work. We use work in our daily life many places, but the physics work is different from the daily work what we do. Work is here force and displacement and making an angle with force and displacement. These are the main thing we have to remember. In the physics, the work depends upon force and work depends upon the displacement and the angle between force and displacement. That is the main thing. And second, power. The rate of work done is called power. Power is work upon time. That is power. And energy, the capacity to do work is called energy. So we have many energy sources in the world. So the energy, different energies. Sun is the direct source for all the energies, you know that. Of course, we discussed some conceptual questions in the 8th class, the work power energy, some conceptual understanding questions. So the first question, the first question is, work done on the system by the resultant force is equal to what? The work done by the system by the resultant force is equal to dash. Actually work is equal to energy. Work is equal to energy. So that's why the work energy theorem, which is nothing but the amount of work done is equal to change in kinetic energy. So option B is the correct answer. So it is not change in mass or both and one, neither one or two. So work is equal to energy, that is change in kinetic energy. So work done is nothing but force into displacement. So that force into displacement, work is equal to force into displacement. So force, mass into acceleration, you can write mass into acceleration into displacement. So mass into we can write acceleration into displacement. V square minus u square is equal to 2as. So that can be written as v square minus u square by 2 you can write. So this is nothing but half mv square minus half mu square. So that is half mv square minus half mu square. That is nothing but kinetic energy. Half mv square is final kinetic energy, half mu square is initial kinetic energy. Final kinetic energy minus initial kinetic energy is nothing but change in its kinetic energy. That's why the option change in kinetic energy is the correct answer. Option change in kinetic energy is the correct answer for this question. So the next question, if you take, the next question is, if the body has mass m, momentum p, then kinetic energy will be what? Option A, p square by 2m, option B, p square by p square by m, p square by 2m, m square by 2p, p by 2m. These are the different options. In this, actually the kinetic energy can be written as, here if you observe, kinetic energy is half mv square by kinetic energy v dot v, you can write mv into mv, that is nothing but kinetic energy can be written as mv into v. So that becomes actually, if you take, mv is that is we can take it as here mv is nothing but the momentum, So that can be written as, okay, so P into P, that is P square by 2m. See, actually kinetic energy is equal to half mv square. Simple way you can write like this. So now you can write multiply with, okay, so mass and divide with mass, that is, okay, m square v square by m you can write. So it means half into, see, this mv into mv, mv into mv you can write like this. So upon m you can write mv into mv. mv is nothing but momentum. Momentum is denoted by p. So p into p, that is p square upon 2m. P square upon 2m. So that is the correct answer. The remaining options are not correct. So kinetic, see, body has momentum, body has mass m, momentum p, then kinetic energy. Kinetic energy in terms of momentum formula, p square by 2m. P square by 2m. Option B is the correct answer for this question. So the next question, if you take, the next question is, see, fourth question, that is, the potential energy of a freely falling object decreases continuously, and what happens to the loss of potential energy? See, when the potential energy of a freely falling object, so for example, object is dropped from certain height to the ground or something, so it decreases. So when potential energy, so slowly it changes and loss its potential energy. That loss of potential energy, what happens? It changes into kinetic energy. Potential energy converts into kinetic energy. The remaining options are not correct. It is not converted into sound energy, not converted into magnetic energy, and none of these. So answer is converted into kinetic energy. Potential energy will be converted into kinetic energy according to law of conservation of energy. Energy neither created nor destroyed. It transforms one form of energy to another form. So energy, so if it disappears in one form and then reappears in another form, here it disappears in potential energy form and it converts into kinetic energy form. So that you can remember. See, this is question number 4. So next question, sixth one. How much is the mass of a man? Okay, so if he has to do, so 2500 joules of work. So in climbing a tree of 5 meters tall. See, here the G value supposed to be given. The G value is 10 meters per second square. So if you take, see here the, what it is given, the work is given. Work is equal to 2500 joules. Work is 2500 joules and you are supposed to find the mass. Okay, see, work is nothing but energy. Energy can be potential energy because it is raised to certain height. So the potential energy is nothing but mass into acceleration due to gravity into height. Mass into acceleration due to gravity into height. So here work is given 2500, that equal to mass you have to find out, and gravity, acceleration due to gravity is 10 meters per second square into height. Height is 5 meters. If you simplify it, so mass equal to 2500 upon 5 into 10 is 50. Okay, so 50 jar 2500, so 50 kg. See, 50 kg is the answer. So 30, 40, okay, so these are the wrong answers. The correct answer is 50 kg. 50 kg is the correct answer. 45 kg is also wrong answer. So this is question number 6. So 50 kg is the correct answer. Next question, that is, a man carrying a bag of mass 25 kg climbs to a height of, see, 10 meters in 50 seconds. Then the question is work done. See, the work done by the man taking bag up to 10 meters height. See, there is a bag is there. So this bag you want to take it to certain height. So the height is, okay, see, 10 meters height. If you want to take 10 meters height, how much amount of work done you should do? See, work is equal to, again here, potential energy, because you are changing its position. So mass into acceleration due to gravity into height. See here the acceleration due to gravity, you have to take it is 9.8 meters per second square. So mass equal to here 25 kg, mass equal to 25 kg, and gravity is 9.8, and height it is given, so 10 meters. So if you calculate this, so 25 into 98, 25 into 98, so that becomes 5 8 ja 40, so 98 25 you multiply, 5 8 ja 40, 5 9 ja 45, 49, 2 8 ja 16, 2 9 ja 18, 19, okay, so 0 5, so how much it is, okay, so 10 14, so 2450. See answer is 2450 joules. See the correct option is A here. See the A is the correct answer, 2450 is the answer, this is the correct one. The remaining options are, okay, see 2400, 2350, 4250, these are wrong options. So 2450 is the correct answer. So the next question, if you take, the work done is always, see there are 4 options are given. See the work done is greater than its energy spent, or less than its energy spent, sometimes greater than, sometimes less than, or equal to the energy spent. I told you already, work done is always equal to energy. Work done is always equal to energy. So option D is the correct answer. Option A is wrong, option B is wrong, option C is wrong. Option D is the correct answer for this question. So next question, see that is 9th question. As a body rolls down on the inclined plane, as the body rolls down, this is the inclined plane, okay, there is an inclination, a body is rolling on this inclined plane, so it has dash energy. So when body is rolling, okay, see it has kinetic energy or potential energy, or both A and B, or neither kinetic energy nor potential energy. So if a body is there at certain height, it has got potential energy. While it is rolling, definitely there is kinetic energy as well as potential energy. See the option C is the correct answer. See, because due to the position it has got potential energy, and due to the motion it has got kinetic energy. So both potential and as well as kinetic energies are there, okay, so in the question. So next question, that is question number 10. See if you take question number 10, in which of the following cases the potential energy of the spring is minimum? There is a spring is there, when spring is compressed, or when a spring is extended, or when a spring is its natural length, or when it is a natural length but it is kept at a height above the ground. See the spring has, okay, so which of the following spring has minimum potential energy? Minimum potential energy will be there due to the position when it is its a natural length. In the natural length, these are the springs, when they are naturally, there is some potential energy will be there. So due to its position, it has got potential energy. So that is the minimum potential energy. When the spring is extended, so different potential energy, it gains its potential energy. So that's why, so answer is when it is its natural length. So next question, see up to 10 there are the conceptual understanding questions, but 11th onwards we have single correct answer type questions. Single correct answer type questions if you take in the work power energy. So the first question, see the power is equal to dash. See the power is equal to dash, force into velocity, force into acceleration, velocity into acceleration, force into time, which is the correct answer. See power is equal to work by time. Power is equal to work by time, you know it. Work is nothing but force into displacement by time. So force into displacement by time. So displacement upon time, the rate of change of displacement is called velocity. So power is equal to force into velocity. Power is equal to force into velocity. In the given options, option A is the force into velocity. The remaining options are not correct, they are wrong. So that's why option A is correct for 11th question. So next question, 12th one. See, the power of an electric bulb. The power of an electric bulb is, so here again the formula. Power is equal to, see, just now I told you, power is equal to work by time. Power is equal to work upon time. See, this work may be electrical work or mechanical work. Work is also converted into energy. The energy consumed upon time. See, the option work is nothing but energy. So energy upon time is also, we can call it as power. Okay, so energy consumed by time taken. Energy consumed by time taken, we can call it as a power. So this is option A is time taken by energy. Wrong answer. Energy consumed into time, wrong answer. None of these also wrong answer. Answer is energy consumed upon time. This will be the correct answer. The next question, so that is 14th question. 1 kilowatt is equal to dash, 1 kilowatt equal to dash horsepower. Horsepower, you know, it is the unit of the power. Okay, so horsepower and kilowatts, watts are the units of the power. See, 1 watt is equal to, 1 kilowatt is equal to how many watts? You should know first of all. 1 kilowatt is equal to 1000 watts. 1 kilowatt is equal to 1000 watts. 1 watt is equal to, okay, so 1 watt is equal to approximately 746 horsepowers. 1 watt is equal to 746 horsepowers. So I want 1 horsepower is equal to, 1 horsepower is equal to 1 upon 746 watts. 1 upon 746 watts. So 1 horsepower, 1 watt equal to, so 1 horsepower is 746 watts. Actually here you have to take like this. Yeah, just listen here. See, 1 horsepower is equal to 1 horsepower, it is given here, 1 horsepower is equal to 746 watts. Okay, so 1 watt equal to 1 by 746 horsepowers. So I want 1000 watts. 1000 watts is nothing but, it is given here, okay, there is a mistake. So 1000 watts is equal to, so 1000 upon 746, this is the correct. So 1000 upon 746. So don't take, okay, see, sometimes there will be mistakes will be there. So be careful when you do it. 1000 watts is nothing but 1 kilowatt. 1000 watts, 1 kilowatt is 1000 watts. So 1000 watts, so 1000 upon 746, 1000 upon 746, that is, you are going to get, it is 1.34 horsepowers. 1.746 1 jar. Okay, say approximately 2000 will come, that is 3 times. 1.34 horsepower is the correct answer. So the remaining options are not correct. Okay, see, 1.34 horsepowers is the correct answer for the, see, 14th question. So next, 15th one, if you take, see, consider the 2 children A and B, they are weighing same. There are 2 children, so they are weighing same. So both start climbing a rope, okay, separately, and reach the height of 8 meters in 5 seconds, and another boy is 20 seconds. See, respectively, the power of the, so A is greater or power of the B is greater, we have to find out. See, here power is equal to always, okay, energy upon time or work upon time. So here time for the first person, power is inversely proportional to time, you can understand. See, the power, here the time taken for the first person, time of A is equal to 15 seconds. Time of A is equal to 15 seconds. Time of B is equal to 20 seconds. So now power is inversely proportional to, okay, see, time. Power is inversely proportional to time. Means, see, power of A, time of A is 15, time of B is 20. So time of B is greater than time of A. Time of B is greater than time of A. So since it is inversely proportional, so power of B will be less than power of A. Power of B is less than power of A. So power of A will be more. See, option A, power of A is more than power of B. This is the correct answer. Power of A is more than the power of B. The remaining option, power of B is more than, wrong answer. Power of A is equal to power of B, wrong answer. Power of B is less than or equal to, okay, so power of A is also wrong answer. Answer is power of A is more than power of B. So A will be, this is equal to power of A is greater than power of B. Simply you can confirm like this. Okay, so next question. So that is 16th question. 16th is maybe repeated or simple question. So next 17th, a man does 200 joules of work in 10 seconds. A boy does 100 joules of work in 4 seconds. Who is delivering more power? Similar question. This is also, okay, see if you take, see the man and so boy. So first we'll take, find out man. So power is equal to work upon time. Power is equal to work upon time. So man does 200 joules of work. So 200 joules of work in 10 seconds means 20 watts. This is the power of the man. So similarly, if you try to find out, okay, see the boy. So the boy power, if you find out, okay, see power of the boy is nothing but again work upon time. So work is here. How much work it is? Actually 100 joules of work. 100 joules of work. See in how much time? 4 seconds. 4 seconds is the time. So 100 upon 4, that is 25 watts. See the power of the boy will be greater than power of the man. So you can confirm here, who is delivering more power? More power will be the boy delivers more power, not man. So that's why, okay, see both same power, we cannot say this is the wrong answer. So option boy, okay, see is the correct answer for the 17th question. So next question, see that is time taken to perform 400 joules of work. Time taken to perform, see 400 joules of work at the rate of 11 watts. See the power is equal to given here, power is equal to 11 watts. So the work is equal to given, it is 440 joules. Okay, see we know the formula, power is equal to, okay, see work upon time. Power is equal to work upon time. Then time is equal to work upon power. So work is 440 joules. Work is 440. Power is equal to 11 watts. So it means 11, okay, so 4 joule. 40, so 40 seconds, the 40 seconds is the correct answer. The remaining 30, 50 and 60 seconds are wrong answer. 40 seconds is the correct answer. You can confirm like that. So next, see 20th question. In the 20th question, if you take, the ratio of kinetic energy of the two bodies 2:1 and their momentum ratio is 1:2. The ratio of their masses in the ratio. See here you have to find out the ratio of kinetic energies. Kinetic energies ratio if you take, see kinetic energies ratio it is 2:1. So K1 upon K2, kinetic energies K1 upon K2, their momentum ratio, so that is P1 upon P2, that is 1:2. You know the kinetic energy ratio and momentum ratio. Masses ratio you have to find out. Okay, M1 upon M2 should be find out. So to find out this, what is the formula we can use? See, the formula is kinetic energy is equal to P square by 2M. Okay, see, you can see P square by 2M. You can use this formula. Kinetic energy is equal to, so you can write the formula K1 upon K2 is equal to P1 square upon P2 square into, okay, so 2M2 upon 2M1. See, I'll write the same formula. Okay, see K1 upon K2 equal to P1 square upon P2 square into 2. Okay, so here M2 upon 2 M1. Okay, see, cancel it. Kinetic energy ratio is given 2:1, that is 2 by 1 you can write. So momentum ratio is given 1:2, so 1 by 2 you can write, whole square into M2 upon M1. So now try to find out. Okay, see, 2 upon 1 equal to 1 upon 4. 1 by 2 whole square is 1 upon 4, that equal to M2 upon M1. So if you take this side, okay, so 4 into 2, 8 upon 1, that is M2 upon M1. But our question is masses are in the ratio. It means M1 is to M2 is equal to, see, 1 is to 8. Okay, so see, in the given option, if you take option D is the 1 is to 8. The remaining is 1 is to 4 wrong, 4 is to 1 wrong, 8 is to 1 wrong. 1 is to 8 is the correct answer. So there is a printing mistake, I think, in the book. Please change. Option D is 1 is to 8. 1 is to 8 is the correct answer. So the next, so I think, I hope you enjoyed the video. Thank you very much. Thank you for listening. Okay.